Going on now to topic 3 in unit 3, we're going to deal with set operations. But I want to review, before we go on, Venn diagrams. Now, these were named after Peter Venn, who lived about 100 years ago or so, or maybe more, where he developed a square to indicate your universe. These would be all the items that we're interested in regard to whatever we're talking about. And then he would put a circle within that to indicate those items that were in a sense, a subset of the universe. And we'd use a capital letter to indicate that. And then we would define what those elements were. And then we also said that A complement was anything that was in the universe that was not in A. And then another review term, something like this, where here there were two subsets in the universe, and these two sets were distinct from each other. Then a third scenario, and again there was universe there and universe there. But now we see that set A has some elements of set B, and set B has some elements of set A. So this shows that there's intersection of the sets. Now, to indicate intersection, you recall, or from our flipped classroom video, we use this symbol. This is the symbol of intersection. And if we wanted to show this in the Venn diagram, we would just shade in this part of intersection. And another term and symbol that we use is sort of like a U, which is union of these two sets. And here, everything would be shaded. And we'll be dealing with this concept throughout this particular lessons and others. All right, let's go on. So in example 1, we're asked to select from these choices the intersection of A and B, which is illustrated here in this Venn diagram that I added. All right, take a moment, read them, and let's see what you have for an answer. So we didn't have to go too far down the list. And again, our little review, I think, was helpful. And notice a number of the other scenarios are described here, but this one is intersection. All right, let's go on. And hopefully a diagram helps, our Venn diagram, where they're asking the difference of A and B. So the difference of A and B. And which letter best describes that? Again, we didn't have to go too far down the list, but you need to read them all. And once again, some other scenarios are described here. But the difference of A and B is those elements in A that are not in B. So you've taken away any elements in B, those that would be intersecting away from A. So now it's just the elements that are part of this A and not the intersection. Now, for these, we need a scenario, a protocol, a modus operandi to do it. First of all, what are they asking? Well, we're going to say set D in union now with set E. So in roster notation, I may have made that too big, but you're going to put those elements that are found in both sets as one. Any element that's repeated, we only list once. So take a moment and see what you get. And generally you want to put them in order. And a note here, just for something coming up. Notice that in set E, the 2's are repeated and the 5's are repeated, but you only write them once. All right, let's go on. Again, we're looking for a protocol to do these. So pause for a moment. You're going to, on your paper for number 4, write the universe. Then you're going to write set A and then set B. And you can position that however you can on your paper. And you have probably lots of room, so don't, squeeze it all together so you can't manage it very well. Okay, now what you need to do is decide what is A complement compared to the universe. Well, in A we have 4, 5, 6, 7. So 4, 5, 6, 7. So the complement is going to be 1, 2, 3. So A complement is 1, 2, 3. That is, those members in the universe that are not in set A. Now we're going to do the same thing for set B. This is set B. Now, what's the complement of B? Well, let's do it this way. We have a 3, 4, and 7 that are in B. So the complement will be 1, 2, 5, 6. So 1, 2, 5, 6. Now you're looking for the intersection of these complements. So which is found in both? Well, 1 is found in both. 2 is found in both. So the answer for this would be in roster notation 1, 2, and that is the protocol to get it. Now, this one was challenging, but again, it's showing the step-by-step following of procedure to get up with a specific answer. Now, for number 5, this is similar to one we had earlier in a previous lesson, where here's a certain park, and there is a certain park, and they're wondering, find the smallest universal set U that contains the listing of trees in both parks. So it would be a matter of a set of braces, and then you're going to choose from down below. And again, unfortunately, part of the list is cut off, but here you're going to include all trees in both, but you only repeat them once, or there are no repeats. And I believe C would have been the answer because there are no repeats here. I would have put them alphabetically. They just listed them. All right, again, you want to know the protocol for doing this, and we did one similar to this already. Now, as you read number 6, you're going to say the universe is this, A is this, B is this, C is this, and D is this. Now, they're asking you to take these two specifics, set C, and then subtract A from it. So in a Venn diagram, what would that be? Well, any elements that were in A and C need to be subtracted. So you only are left with this portion. So take a look and see which letter would suit that. Remember, it's C minus A. So anything that was of intersection is going to be taken away. What statement do you get? So I added, again, what C specifically was, is all tax forms filed in 2008. A was tax forms with standard deductions. Now, there should be an overlap. So what would C be after you subtract A from it? Would be the set of all tax returns filed in 2008, but without, now, standard deductions. In example 7, we're going over cardinal numbers of sets, and I've developed a little example here to help maybe interpret this. So this is going to be the cardinal number of the union of A and B. So we can just count them. There's 1, 2, 3, 4, 5, 6. So for this part, there are 6. Now, what is the number of A? Cardinal number of A is 4. What is the cardinal number of B? That's 3. So we say then that the cardinal number of the union of them is the sum of these, which so far is 7. But now we are subtracting the number that are intersecting. Well, there's only one item intersecting, so this part will be a minus 1, and we end up with a 6 here. So what do you think? This is always going to be true, as long as we have intersection. And maybe others too. All right, let's go on. Now for number 8, we're looking at this and we want to determine whether this is a true statement or not. Well, these are sets in roster notation. Do they have exactly the same elements? Yes. So they are equal. And then this is true. But you might say, how about they're a different order? Well, in sets, let me write this out here. You can write it on your paper too. In sets, order is not important or significant. Can choose either word. Now, how about this as a statement? 2, 3, 3, 2. Now, these aren't sets. These are ordered pairs. We're using a parenthesis here. Now, is this true? Is order important in ordered pairs? Yes, order is important there. So this is not true. Or to make it true, we'd have to say that they do not equal each other. All right. Again, we're doing a review. And if you have a question on something you're not sure, be sure you're asking. Now, this is a little tiny and a little hard to read. But notice we're dealing now with a Venn diagram with 3 sets, and they overlap. So we're saying this is A, this is B, and this is C. Now you want a protocol to fill this in. And on your paper, make it big enough so that it's easy to separate things and to put items in. Now here they're giving us the universe. Then they're set A, set B, set C. And they want you to place the letters in the appropriate spots. Now, if a letter is found in all three, let's see if there is one. So we have a G. Yes, G is. So I'm going to put in mine, and see, I don't have much room. I made it too small. But you're going to put a G there. Anything else? H. No. And again, if it's only found in A, an H looks like it's only found in A. Let me see. H. Kind of hard to see. Then you'd put the H there. And then it's a matter of selecting which one of these would be your answer. So far, just looking at it, here we have a K, so that's not it. This has a G, that's not it. Now, as I look here, I see there is a J in both. Again, it's hard to see, so there's also a J in there. All right, so as you fill this in, and I think I gave you a good example in our flipped classroom lesson of how to do this. This is what you're going to have to do, and then you pick it out. So far it looks like this could be a possible, this could be a possible. Now, that's only in A. Some others here, you're going to have to look at that very carefully and select it. And for our last example, look what's written and then see what statement seems to make this valid here. All right, I think it's C, because A would equal A, and we're subtracting an empty set, so in a sense this is nothing. A will always equal A. All right, let's wind this up. You'll be doing your homework, and again, bring any questions in that we can help you with.